Picking back up, sorry about that. I stopped after the second example because announcements went on during advisory. Number 3. So I can see that they both have the same exponent. So I'm going to pull that exponent out of both. And I'm going to write 192 over 3. Then the entire thing gets raised to the negative third power. You only can do that when you have the same exponent and you're multiplying or dividing. Now let's take 192 and divide it by 3. We get an answer of 64. If you look on the notes from last Monday, or recognize that 1/2 is the same as the square root. The square root of 64, is 8. And now I'm going to take 8 to the negative 1/3. Again, we have a negative exponent, which says this 8 isn't happy where it is. It's currently on top. We're going to move it to the bottom. Now it's happy, so we change the negative 3 as an exponent into a positive. And now let's see, what is 8 to the third power? 8 to the third power is 512. This is equivalent to 1 over 512. Number 4. Okay, I have the same base. When you have the same base and you're multiplying or dividing, we're going to add or subtract the exponents accordingly. So same base and dividing, we subtract the exponents. And I'm going to use the calculator to make life easy. Remember to use your parentheses. 15/4 subtract 71 divided by 20. Once you get an answer, you're going to turn it back into a fraction by hitting math, fraction, enter, enter. So now we really have 32 raised to the 1/5. And if you look back to your notes from Monday, look into the column, the 5th column, and find 32. You'll see that 32 to the 1/5 is equal to 2. Or if you don't happen to have those notes from Monday, we can go 32 raised to the, make sure to put 1/5 in parentheses, and we can see the answer is also 2. Number 5 is much like number 1. I'm going to take this 3/2, I'm going to apply it to both the 81 and the x to the negative 6. The biggest mistake I see students make is forgetting to apply this to the 81. Right now we have 81 to the first and x to the negative 6th. And I'm going to apply 3/2 to both. 3/2 times 1 is just 3/2. And this becomes negative 18 over 2. And I know that negative 18 divided by 2 is negative 9. Okay, let's take care of 81. First, we always apply the bottom number first. 81 to the 1/2. Afterwards, we'll raise it to the third. So, half of 81. Remember, this 1/2 really means a square root. So you can look into the second column of Monday's notes. You can use a calculator if you've forgotten the 1/2. Again, 81 raised to the 1/2. And you're still going to get the same answer because we know the square root of 81 is 9. I've evaluated this portion. I have a 9. We'll apply the 3 afterwards. Now 9 to the third. Common mistake is students say 27. We'll use the calculator to evaluate. 9 to the third means 9 times 9 times 9, which is 729. X to the negative 9th. 729 is happy because it has an exponent that's positive. The x is not happy because the exponent is not positive. 729 will stay where it is. The x will move to the bottom and become positive. Number 6. Notice we have the same nth root. You can only do this when you're having the same nth root and you're either multiplying or dividing. So I'm going to make a large radical here. Because we have the same nth root, I'm going to do 54 over 2, x to the 25th over x to the 1st, y to the 37th over y to the 4th. Now I'm going to reduce using the skills that were taught to you last semester. 54 divided by 2 is 27. Remember, when you have the same base and you're dividing, you subtract exponents, top minus bottom. 25 minus 1 is 24. 37 minus 4 is 33. Now I'm going to apply the nth root, which is 3, so the cube root. Feel free to look into your notes from last Monday, find the third column, and find 27. We can see 27, the cube root of 27 is 3, or grab your calculator, 27 to, we don't just say 27 to the third, it's 27 to the 1/3. The cube root of 27, this is where you guys can see it, is 3. Taking care of this portion. Now we're going to take each one of the exponents on the variables and we're going to divide by 3. 24 divided by 3 is 8. 33 divided by 3 is 11. There's our simplified answer. Going to number 7. Number 7 is somewhat similar to 3 and to 4. I'm going to rewrite this. I see the nth root is a hidden 2. So I'm going to go 245 divided by 5, raised to the 1/2 power because they have the same exponent, and lastly raised to the -5. So let's take 245 and divide it by 5. 245 divided by 5 is 49. On your columns with the nth roots, find the second column. We can see 49 is there. And we know the square root of 49, because 1/2 represents square root, the square root of 49 is 7. 7 to the -5. This says 7 is not happy. So I'm going to move it from the top down to the bottom and make it happy. Now I'm going to take 7 to the 5th on the calculator. And 7 to the 5th is a large number, 16,807. Okay, on to the next one. Number 8. Because we're dividing, you can only do this with multiplying or dividing, but because you're dividing and you have the exact same exponent, I'm going to pull out the 5s, and in parentheses I have the quantity 27 divided by 3. 27 divided by 3 is 9. Now before I go to the effort, like we've done on the previous problems, and go 9 to the 5th power and get this large number and then apply these, I can see a similarity. You see how I have 5 on top here and 5 on the bottom? I know that you've learned that when you have an exponent raised to the higher exponent, you multiply. So I'm going to multiply these. -10 over 5. And -10 over 5 reduces to -2. The -2 says 9 is not happy where it is, so it's going to go to the bottom and become happy. And 9 squared is 81. On to number 9. On to number 9. I'm going to take this, notice it's a negative, and apply it to the 144 and to the x to the -1/4. Okay, so remember, we're going to multiply. 1 times -1/2 is -1/2. And -14 times -1 is 14. 14 divided by 2 is 7. The 144 is not happy because it has a negative exponent. So I'm going to move the 144 to the bottom and make it happy. And the 7, x to the 7th, is happy because the 7 is a positive exponent. Okay, remember that 1/2 is the same as taking a square root. The square root of 144 is 12. You can find that on your chart. Or if you didn't know that, you could type in 144, raise it to the 1/2 power in parentheses, and you still get the answer of 12. On to number 10. Number 10 is going to be very similar to number 6. The nth root is a hidden 2 because you have the same nth root and you're dividing. Make one large radical here. 8 divided by 2, x to the 6th over x to the 2nd, y to the 24th over y to the 2nd. Remember, we have a hidden nth root of 2. So 8 divided by 2 is 4. And we're going to subtract exponents. When you have the same base and you're dividing, you subtract exponents. 6 subtract 2 is 4. 24 subtract 2 is 22. So what does this mean? Remember, this is really just like a normal square root that you learned about years ago. Square root of 4 is 2. And now I'm going to use this nth root and put it underneath each of these numbers. 4 divided by 2 reduces to 2. 21 divided by 2 reduces to 11. It may be helpful for this problem to take out the chart we've been referring to from last Monday. Find the fourth column. In the fourth column, you're not going to find the number 2. But when you look into that column, what you will see, and if you're looking in the right column, so x to the 4th, you're going to find numbers 1, 16, 81, 256, and so on. Okay, I want to turn this bottom number by multiplying into one of these numbers, and preferably the smallest one. So how do I turn a 2 into a 16 by multiplying? I multiply by 8. I'm going to rewrite this in rational exponent form, which just means the exponent is rational. It's a fraction. So I write it over 1/4 and over 1/4. Now I need to turn this into 16. And I do that by multiplying the top and bottom by 8 to the 1/4. We multiply the top and bottom by the same number to keep this value the same as above. Because we have the same exponents, 2 times 8 is 16 to the 1/4 and 8 to the 1/4. We can look back to that chart. We can see that 16 to the 1/4 is really equivalent to 2. Or if you didn't have the chart, 16 raised to the 1/4 is 2. Common mistake I've seen in the past is students want to take it one step further and go 8 divided by 2 is 4. Can't divide these, you don't have the same exponent. Number 12. Well, first let's reduce. 7 over 56. Let's go 7 divided by 56. Then hit the button on the calculator that says math, fraction, enter, enter. So it reduces to 1/8. I'm going to first apply the bottom number of the fraction. So let's take 1/8 and let's take it to the 1/3 power, and then afterwards we'll deal with the -2. So what is 1 to the 1/3 power and what is 8 to the 1/3 power? Well, 1 raised to the 1/3 power should just be 1. And 8 raised to the 1/3 power should be 2. So on top, when I distribute the 1/3, I get an answer of 1. And then the denominator, when I distribute the 1/3, I get an answer of 2. Now I'm going to apply the -2. So it applies to both the top and to the bottom. So 1 to the -2 and 2 to the -2. That says the 1 isn't happy, it goes to the bottom and becomes happy. The 2 isn't happy in the bottom, it goes to the top and becomes happy. Now we can evaluate. 2 squared is 4, 1 squared is 1, and 4 divided by 1 is 4. Select all of the select all equivalent expressions to this. Well, I'm going to rewrite this. Remember to rewrite it, this nth root always goes on the bottom. This number is going to go on top. So let's reduce if you're not good with reducing. Take 5 divided by 35, hit math, fraction, enter, enter. Okay, so x to the 1/7. So do I see anything that's x to the 1/7? Well, I know that 3 goes into itself 1 time, and 3 goes into 7, or to 21 7 times. So these are equivalent. And you could check that by going 3 divided by 21, hitting math, fraction, enter, enter. You see you have the exact same rational exponent. Okay, this one, if I rewrote option E, remember that the nth root always goes on the bottom. 70 in this case goes on top. 70 over 10 reduces to 7, not 1/7. This would reduce to 7, not 1/7. The hidden nth root here is a 1. So if I'm rewriting this, remember nth root goes on the bottom, 7 goes on top. Again, this is x to the 7th, not x to the 1/7. Here the nth root is 7. It goes on the bottom, and the hidden 1 outside goes on top. So this is equivalent to this. So right now I have option F and option C that are equivalent to this. Again, nth root is a 1. That goes on the bottom, outside is a 7. 7 is not the same as 1/7. 35 divided by 5 is 7. X to the 7th is not the same as 1/7.